Hi, this is going to be my first user-submitted question video. I had a question about one of my limits videos. Someone was having trouble with a specific question, and I'm going to go ahead and go over that so they understand it. I'm pretty sure this is what the question was. It wasn't clear from the comment exactly what it was, but I'm going to show you how to solve this limit here. So we'll start. It's the limit as x goes to 0 of 1 over 2 plus x minus 1 half all over x. Now, just off the bat, this limit looks pretty challenging. You might not know where to start with it, but usually the route to go with these crazy questions in the beginning limit section before you get to L'Hopital's rule, which is something you'll learn when you do derivatives, is to try to rearrange what you have to turn it into something that makes more sense and that can be solved. And so let's go ahead and begin with this. Now the first thing we're going to want to do is distribute this x to each of the terms here. So this is going to be, okay, I'll make my pen size a little bit bigger here. So 1 over 2 plus x is just going to be 1 over 2 plus x times x minus 1 over 2x. And for now, I'm going to leave off the limit as x goes to 0 out of the front here, just so we can rearrange this, and then I'm going to bring that symbol back in. But throughout my explanation here, it's implied that this limit as x goes to 0 is still here. So, anyways, now that we have that out of the way, we have this here. Now, this is slightly more simplified, and it still doesn't quite look manageable. So let's try to simplify even more. We want one big term, not this thing split up all over the place. So we want a common denominator. And how we do that is, let me just rewrite this so we get 1 over 2x plus x squared. And then minus 1 over 2x. Alright, so now we multiply 2x on the top and bottom. Should be a multiplication sign there. 2x on the top, 2x on the bottom. And so we're effectively multiplying by 1. We're safe to do this, as you probably already know. And so hopefully this makes sense. We're going to multiply by the same thing on this side. And then over here, we're going to multiply by 2x plus x squared on the top. And 2x plus x squared on the bottom. And so you should already be pretty familiar with this. But just to be clear, what we're doing here is multiplying out here so we get a common denominator, and then we can simplify. So let's just go ahead and do this algebra. So we'll start with this first term here. On the numerator, 2x times 1 is going to be 2x. And on the bottom, we're going to say 2x. Okay, this should be like this. We're multiplying times the whole thing. So 2x times 2x is 4x squared. And then 2x times x squared is 2x cubed. Okay, and on this side, this is easy, multiplication by 1, so we'll have 2x. Actually, since these are the same here, top and bottom, I'm just going to go ahead and extend this, and we're subtracting by minus 2x plus, oh, this is a subtraction goes to both of these, so this is going to be minus x squared. Alright, so I hope this makes sense to you. Let me just rearrange this a little bit. So what we have here is just a simplified version of what we had in the original equation, no, so original, not equation, expression. So now that we have it broken down into this, we can simplify a little bit. The first thing I notice is this 2x minus 2x should go away. That just goes to 0. And we can drop an entire x squared out of this. And what I mean by that is, I'll just rewrite this, minus x squared over 4x squared plus 2x cubed. So now what I notice is we can, I'm going to move down here and copy this so we can manipulate it. So now we can factor an x squared out, so this is equivalent to, I'm just going to bring it out here, x squared times negative 1 over x squared times 4 plus 2x. And so now we see something interesting. This x squared is going to cancel. Now, the one thing you're probably wary of about just canceling the x's here is we can't just cancel an x term if we have to make sure that nothing's going to go wrong. But what you want to see in a limit is an x over x, an x canceling, because that means you're removing that 0 over 0 form. And if that doesn't make sense, don't worry about it. But if you see x's canceling, if you remember from the other limits videos, this should be good news. So I'm going to go ahead and cancel these. And now this is going to be equal to, I'll move down a little bit more again. Oop, okay. Let's see. Now this is going to be equal to negative 1 over 4 plus 2x. Now I'm going to go ahead and write in the limit as x goes to 0 that I've been ignoring here the whole time. So let's look at the question again. What happens as x goes to 0? If we plug it in here, this is going to be negative 1 over 4 plus 0. 4 plus 2 times 0 is 0. And then there you go, that's negative 1/4. That's the answer. And so we see that to get to an answer like this, all you really have to do is take what you have in the original equation and play with it, rearrange it, use trig identities if you have some trig functions in there, and you should get it to come out to a clean function like this. And this is much easier to do than our original form, but the art is being able to break it down. So hopefully that made sense, and please make sure to leave a comment. Again, if you have a question, I'm always happy to help. And so thanks for watching, and I'll see you in the next video in derivatives.